So today I have to discuss again on nitrene. Okay. So already I discussed about what is nitrene. Nitrene is an intermediate. Okay. And that is non-ionizable, that is short-lived, that should be highly reactive and electron deficient, that behave like carbene, like electrophilic in nature. Okay. And there must be so many example I already discussed. And then preparation procedure, that should be alpha elimination, that should be from azide, from immunodense, by photolysis of hydrozoic acid to alkyl isocyanate, and oxidation reduction method. So in various pathway we can produce nitrene intermediate. Okay. And also this is the types. This is the types of nitrene. Okay. But now the question arises, that is the utility of nitrene intermediate. That is fine, that is nitrene is produced, how that is produced, the lifetime, all are right. Okay. But the utilities of nitrene preparation we have to know. ओके आपका जब नाइट्रीन प्रोड्यूस हुआ नाइट्रीन आपका क्यों प्रोड्यूस हुआ वो ठीक है, हम जान गए, प्रीवियस लेक्चर में आई ऑलरेडी डिस्कस्ड. एंड ऑल्सो उसका जो प्रॉपर्टीज होता है वो भी मैंने बोला, राइट. पर उसका प्रोड्यूस तो हो गया, उसके बाद उसका यूटिलिटी क्या है, राइट. आफ्टर प्रोडक्शन व्हाट इज द यूटिलिटी ऑफ नाइट्रीन इंटरमीडिएट, राइट. ओके, so that's why we have to know the reaction of nitrene. The reaction of nitrene. Okay. How nitrene used in various purposes. Okay. First one, nitrene is an electrophilic in nature. Okay. And so it having also one extra lone pair. Suppose this lone pair, these two lone pair behave like in that way, that can be donate in that way and accept in that way and produce this type of compound. Okay, like carbene का देखो, एक carbene electrodeficient, that's okay. Carbene electrophilic, that's okay. But when carbene accepts some electron from any source, it also donates this extra electron to same source or other source. Okay, so simultaneously carbene behave like electron acceptor and electron donor. Similar things that should be happen for the case of nitrene. Nitrene in one hand electron accept, in other hand electron donate. Okay, as for example, in bus, when bus that should be going on, there must be some people, what, some people क्या बोलता है, बस से क्या होता है, नीचे आता है. Some people outside of the bus as their destination reached. Okay, and some that all are go inside of the bus because they have to reach their respective destination. Okay, this is the thing. In train or in plane or in anyhow, some people go outside, some people go inside. Why? Because some people go, they have to go in any destination, and some people already come in their respective destination. Okay, this type of things when carry on in a simultaneous manner, these thing can be visualized as a nitrene or carbene interacted with any other species. Okay, I better clear it. Suppose, as for example, what I have to say, that is, okay, suppose you have to do BSc, okay, after schooling and before masters, right? Why? Because BSc is a bridge of both of the two steps, both of the two levels, right? If you go that is from schooling to directly to the masters, you never understand many things. because our understanding level that should be go step by step. Okay, so that's why BSc is important in between of bridge of masters and schooling. Okay, so these things, what is the utility of BSc? It bridge with the schooling or school level and gain the previous knowledge of school level. Okay, and also it make the preparation, making the perfect knowledge to go the masters. Okay, that means in one hand it gains something, the previous knowledge it gains something. Okay, previous knowledge that should be accepted, and then it donate some knowledge to the students for preparing for masters, right? So this is the bridging tendency. 19 भी ऐसा ही काम करता है. 19 in one hand, suppose in left hand it accept electron from pi cloud or any other electron dense system, and then it never carry on the extra electron density, so it can be able to donate its extra electron by right hand. Okay, so these things can be happen in that case. Okay, 19 एक हाथ से इलेक्ट्रॉन लेता है, दूसरा हाथ से इलेक्ट्रॉन देता है, right? Okay, so that's why this is produced. Again, there must be 19 that type of compound produced. Okay, then here 19 also produce this type of ring compound. Ring formation can also be happen by 19 intermediate. That is also utility, and you know that this ring is much more stable than the acyclic counterpart most of the cases. Okay, right? And if there is stability not gained, sometimes we have to prepare the ring compound due to some future work, due to some laboratory work, due to some urgency, due to some utilities. So that's why it is also a application that 19 can produce a ring compound and which having nitrogen. आपका नाइट्रोजन वाला एक रिंग भी प्रोड्यूस कर सकता है 19. ये बहुत बड़ा एक एप्लीकेशन है. ठीक है. नेक्स्ट वन, इंसर्शन रिएक्शन. 19 कैन बी इंसर्टेड. हाउ? दिस हाइड्रोजन कैन बी attached with nitrogen and nitrogen can be inserted in between carbon hydrogen bond. Okay, कार्बन हाइड्रोजन बॉन्ड के बीच में नाइट्रोजन आ जाता है. ठीक है, इसको हम बोलते हैं इंसर्शन. सोचो, एज फॉर एग्जाम्पल, यू एंड योर एल्डर सिस्टर, ओके, goes to the you and your elder sister go to the market. Suppose your one younger brother come and they stand between of you and your elder sister. So that means what? Your younger brother inserted in between of the bond of you and your elder sister, right? Okay. आप और आपका बड़ा बहन जा रहे हो. कहाँ जा रहे हो? मार्केट में जा रहे हो. तो सोचो, रास्ते में आपका एक छोटा सा ब्रदर, छोटा सा एक भाई के साथ आपका क्या हुआ? मुलाकात हुआ. तो वो आपके और आपके बहन के बीच में खड़ा हो गया. ठीक है. तो जो बॉन्ड है वो आपका और आपका जो बहन का जो बॉन्ड है उसमें इंसर्ट हो गया. तो उसको हम क्या बोलते हैं? इंसर्शन. कोई आकर ऐड हो गया बॉन्ड के बीच में. ठीक है, बॉन्ड के बीच में कोई आकर ऐड हो गया, उसको हम बोलते हैं इंसर्शन. एनीथिंग दैट शुड बी एडेड इन बिटवीन अ बॉन्ड, that is called insertion procedure, insertion process. Okay, insertion. Okay, what is called insertion? Insertion is nothing but that is a group or any element that should be added in between of two atom or in between of a particular bond. Okay, here 19 added or 19 inserted in between of carbon hydrogen bond. Okay, in 19 there also rearrangement can be take place. Okay, how? Already I say that in carbocation, carbanion there are already many type of rearrangement can be take place. Why? Because the driving force to gain the maximized stability of intermediate. राइट आपका कार्बोकैटायन में रिएरेंजमेंट हो रहा है, मिथाइल शिफ्ट हो रहा है, हाइड्रोजन शिफ्ट हो रहा है, फिनाइल शिफ्ट हो रहा है. ओके, व्हाई? द ड्राइविंग फोर्स क्या है? आपका stability of carbocation, right? The hydrogen shift, methyl shift, alkyl shift, all that should be done to get the most stable carbocation. Okay, and why most stable and carbonyl? We have to rearrangement to produce the most stable carbonyl, right? Similar thing can also be happened from nitrene. Nitrene itself is not a good stable compound. Okay, so that's why it can be rearranged and produces stable, that is more stable compound, that is isocyanate. Okay, how? This lone pair go this way and this alkyl group go this way. Okay, in one hand it donates its one lone pair, and in other hand it accept the extra alkyl group. ओके पहले जो हो रहा था एक हाथ से इलेक्ट्रॉन दे रहा था, एक हाथ से इलेक्ट्रॉन ले रहा था, यहाँ पर ऐसा नहीं हुआ। यहाँ पर वो एक्स्ट्रा इलेक्ट्रॉन दे दिया, उसके बाद उसके बदले वो क्या किया, एक अल्काइल ग्रुप ले लिया, राइट। नेक्स्ट वन now we have to go, that is nitrene in a NEM reaction. Nitrene intermediates having high utility in such NEM reaction like Cartesius reaction, Hofmann rearrangement, Schmidt reaction and Lausanne rearrangement. In those reactions, nitrene having high utility. Why? Because nitrene produces some compound which never be generated in other way. That's why. Suppose in Cartesius reaction there must be this acidic proton that should be abstracted, then in negative charge go this way, alkyl group that should be shipped to the nitrogen, and so that's why N2 that should be released, so ultimately isocyanate can be produced. आपका N नेगेटिव की जगह आप दो एक लोन पेयर भी आप कंसिडर कर सकते हो, क्योंकि दो इलेक्ट्रॉन मिलकर ही एक नेगेटिव चार्ज होता है। तो वो गया है कहाँ पर, कार्बोनिल के बगल में, तो इसलिए जो आर ग्रुप है वो बेक करके नाइट्रोजन के तरफ चला गया, तो उसके साथ क्या हुआ, N2 रिलीज हो गया, एंड N2 ऑलवेज टू बी ट्राई टू लीव फ्रॉम द कंपाउंड. व्हाई? बिकॉज N2 itself is a stable gas. And when in any reaction, any gas when released, that is entropically more favorable, right? So that's why isocyanate can be produced. And there must be another driving force is isocyanate is much more stable than nitrene intermediate. So that's why this rearrangement can be favorable. Next one, evidence. What is the evidence? Alkyl azide. There must be produced nitrene first, and then there must be isocyanate can be produced. Application, this type of compound can be used. There this C2H5 convert into CONH and H2, and then there must be nitrous acid. What is used in that reagent? This is homework to you. I never give, because you have to first identify which one reagent. That is also important, reagent detection. In many type of entrance tests where reagent never be given, you have to choose which one is given. I willingly miss this reagent because you have to find out first. Okay, मैंने जानबूझकर आपको reagent नहीं दिया. Why? Because आपको पहले जानना है कौन सा reagent यहाँ पर हो सकता है. Then you have to say in the comment section. I will then check and then I will reply it. Okay. So nitrous acid, that should be used. Nitrous acid is a combination of what? Nitrous acid ऐसे नहीं मिलता है. Nitrous acid high tendency to oxidize to produce nitric acid. So nitrous acid lab में ऐसे नहीं मिलता है. Nitrous acid never be available easily in lab, because nitrous acid always to be converting nitric acid. Okay, so that's why nitrous acid always be produced in situ by the reaction of sodium nitrite plus hydrochloric acid. When you mixed it, and that should be used, that behave like as nitrous acid, because in situ procedure nitrous acid produced. Then there must be azide can be produced, heat can be introduced, so cyclic compound can be produced. Then ultimately this is also your homework, this beta phenylalanine can be produced. Beta phenylalanine is an artificial amino acid. Why? Because most of the amino acids are alpha amino acid, and when you consider beta, दिस बीटा फिनाइल एलानिन एक्चुअली नेवर एग्जिस्ट इन नेचर, नेचर में नहीं मिलता है, दैट शुड बी प्रोड्यूस आर्टिफिशियली. सो बीटा फिनाइल एलानिन इज नेवर बी ऑकर इन नेचर way. Okay, that should be always prepared by artificial way. Next one. Now Hofmann reagent. In Hofmann reagent, there must be propanamide. कोई भी आपका amide हो, any type of amide that should be react with Br2 KOH, and there must be benzylamine, that is amine produced, along with side product 2KBr, K2CO3 potassium carbonate, and water can be released. That means DRS, that should be positive. Okay, positive or negative, I have to check. Okay, next one mechanism, there must be amide, Br2 KOH can be used, that is Hell-Bola-Jelinek reaction. Then there must be one hydrogen replaced by bromine, and then this OH abstract the proton, this acidic proton. Why? Because in one side there must be this carbonyl group is there, in other side Br is there. So high minus I effect, there are also minus I effect. There are also minus I effect, and Br also show minus I effect. That's why this hydrogen is much more acidic. So when acidic, this electron can be behave as 2 electron, that also can be behave like as carbon type. Okay, so that's why it can be go this way, and this R group can be go this way, and Br group that should be released. Okay, after Br release, there must be alkyl isocyanate can be produced. When water react that side, there must be this type of this way come, and again this way come, then again their नेगेटिव चार्ज कैन बी देयर. ओके, आपका जो भी CO हो ऐसे होता है, तो उसके बाद CO नेगेटिव होता है, उसके बाद वो फिर से आता है. तो ये जो दो स्टेप यही तो हम यहाँ पर दिखाए. ठीक है. नेक्स्ट, and N-alkyl carbamic acid can be produced, and after that their decarboxylation, that means their negative charge that should be released this way, that should be released this way. So RNS2 can be produced. Okay, next. Application, succinamide, that is CH2, here CONH and here CO. Okay, that means if you consider NH, CO, CH2, CO. Okay, then when OH can react in that way, this bond that should be cleaved, and so this is produced. Again BrH when produced, this CO that should be released, so that's why this type of compound can be produced. After H plus, COOH can be abstract H plus, so beta alanine again produced. Okay, if you consider COOH, this is alpha, and this position beta. This position alpha, this position beta. Okay, in that beta position, this beta position, NH2 is attached, so that's why this is called beta alanine. Next one, Smith reagent or reaction. It can be called as reagent, it can be called as reaction. So which NaHN3 use, there must be with adding acid, sulfuric acid, amine produce, CO2 that should be released, N2 that should be released. Okay. So in acid, that should be hydrogen abstraction can be there produced. Again this N negative react and that way, and this bond that should be marked, so this is produced, and again hydrogen go OH that should be go, there must be this is produced. Okay, next. Again N2 release, so that's why this hydrogen go this side, and this R group go this side, so ultimately isocyanate not, that is NR double bond C double bond O that should be produced, and then again water that should be react that way, this carbonyl, and there must be also this delocalization can be there, and ultimately negative charge can be go on nitrogen. Okay, nitrogen. Or you can produce a middle compound, like as for example, suppose there O2 reaction can be there and there must be OH produced to COH. Again when COH decarboxylation can be there, so this way there must be amine produced and along with CO2 release. Okay, there, so that's why their heat can be used. आप ऐसे भी दिखा सकते हो कि डायरेक्ट आपका डिकार्बोक्सिलेशन हो गया, आप एक स्टेप फर्दर करके भी दिखा सकते हो कि वहाँ पर डिकार्बोक्सिलेशन हो रहा है, CO2 रिलीज हो रहा है, उसके बाद एमिन हो रहा है, राइट. ओके, लास्ट रिएक्शन दैट इज लॉसेन रिएजमेंट, or that can also be called as reaction. Some reaction never be called as reagent, because in all reaction the reagent never be occur. Okay, and also some reagent never be called as reaction. Okay, but some common reactions are there which can be called as reagent, which can be called as reaction. Okay, so what I tell, Smith reaction, Lawson reaction, they are also reaction, they are also reagent, because there must be reaction properties can also be followed and reagent can also be occur. That's why. Okay, now hydroxamic acid. Hydroxamic acid means what? There should be carbonyl is present and there should be NaOH is present. That is called hydroxamic acid. And when this OH group, when substituted by acyl group means OCOR. OCOR, that should be called as acyl. This group is called as acyl. Okay, when attached, that is called acyl derivative of hydroxamic acid. When OH used, OH should be attacked in that carbon, right? Not that carbon. OH will abstract this acidic proton. Okay, so there must be negative charge can be there, and this negative charge can be rearranged in that way, and so acyl group that should be eliminated. So acyl group eliminate, so this compound is produced. This is a middle compound. This is not a so much stable, that is not a, so that's why this is not a अल्टीमेट कंपाउंड. जो NR डबल बॉन्ड C डबल बॉन्ड वो होता है, और जो आइसोसाइनेट कंपाउंड होता है वो मिडिल कंपाउंड होता है. वो कोई इंटरमीडिएट नहीं होता है, पर वो कोई फाइनल प्रोडक्ट भी नहीं होता ज़्यादातर. ओके, उसके बाद भी फर्दर रिएक्शन होने का चांस होता है क्योंकि वो हाईली रिएक्टिव होता है. ओके, so then water when react, there must be RnH2 and CO2 can be produced. And remember that in electron donating group, accelerate the reaction in case of nitrene. नाइट्रीन का कोई भी रिएक्शन हो, वहाँ पर अगर आप इलेक्ट्रॉन डोनेटिंग ग्रुप इनकॉर्पोरेट करो तो रिएक्शन का रेट बढ़ जाएगा, और अगर इलेक्ट्रॉन विड्रॉइंग ग्रुप आप दे दो तो रिएक्शन का रेट घट जाएगा. ओके, सो व्हेन नाइट्रीन, if you introduce electron donating group, so the reaction rate that should be increases. If you use electron withdrawing group, the reaction rate that should be decreases. And all the things that should be taken from various type of reference books. Okay, so what I already say, that is nitrene is a non-ionizable, short-lived, obviously very less time it can be exist. Highly reactive, obviously very highly reactive, and electron deficient species like carbene having 6 electron on nitrogen, so never be having octet, so never be stable in terms of electronic configuration, and so chemically reactive. Okay, it's need electron because it never fulfill its octet, because it is a 6 electron species. ये 6 इलेक्ट्रॉन स्पेसिस है, इसका ऑक्टेट नहीं हुआ है तो इसका इलेक्ट्रॉन का हर वक्त स्कार्सिटी रहेगा, एक क्या होता है चाह रहेगा, मतलब उसको पाना है इलेक्ट्रॉन. ठीक है, तो इसलिए इतना हाई रिएक्टिव होता है, इलेक्ट्रोफिलिक होता है. और इसका जो मैंने बोला ही है, also called agene, also called imines, also called imidogens. The simplest form are alkyl nitrene, acetyl nitrile. All nitrates are derivative of NH. Nothing but if you have to replace the hydrogen by alkyl, so this is alkyl nitrene. If you replace hydrogen by acyl, so that should be acyl nitrene, and so on. Okay, now preparation. First one, alpha elimination. This there must be Br. Most of the cases Br show plus R effect and minus I effect, right? Br क्या show करता है, plus R और minus I, but most of the cases this halogen group show minus I predominant. Very few cases plus are effect. Okay, so that's why most of the cases we have to consider minus I. And here also this is not an exception. Here also halogen behave like as a minus I effect group. So there must be minus I effect, and this CO also show minus I effect. So due to this hydrogen acidic, so base have stuck it, so N negative, and this N negative can be produced ultimately actually N negative, but still nitrogen having one extra lone pair, so that's why this is behave like nitrene. Okay, nitrene, there must be two electron that should be present in two different orbital, and also one electron having one electron, and this is a type of what? This is type of triplet nitrene. Okay, this is a triplet nitrene. Next one, from azide, this is very simple. N2 always try to be eliminated because N2 is stable. So N2 when release, obviously gas is release, so गैस मेकिंग मोर रैंडमनेस. जब भी कोई भी प्रोसीड्योर में आप देखोगे गैस रिलीज हो रहा है तो गैस का रैंडमनेस सबसे ज़्यादा होता है. इतना ज़्यादा होता है कि वो लिक्विड और सॉलिड बहुत सारा आप रिलीज करो उससे बहुत गुना ज़्यादा होता है. तो कोई भी प्रोसीड्योर में जब आप देखोगे गैस रिलीज हो रहा है तो वो एंट्रोपिकली मोर फेवरेबल होना चाहिए. ठीक है, उसके साथ कार्बन हो रहा है. फ्रॉम इमिडोडेंस, हेयर ऑल्सो यू हैव टू यूज फोटोलाइसिस और हीट प्रोसीड्योर. देयर ऑल्सो ARI कैन बी प्रोड्यूस. ऑब्वियसली यू नो दैट इज halogen haloarin, they are stable, so that's why this nitrene can be produced. Next one, types. There must be singlet nitrene, there must be triplet nitrene, as like as carbene. Okay, in singlet nitrene there should be paired electron, in triplet nitrene there should be unpaired 2 electron in 2 orbital is there. Okay, next one, photolysis procedure, there also N2 release, and so from hydrogen acid this nitrene can be produced. Here also from alkyl isocyanate CO release, so nitrene can be produced. Then oxidation reduction procedure, when compounds contain NH group are oxidized with lead tetraacetate, activated mercuric oxide, manganese oxide, so there also nitrene should be produced like this. Pb acetate can be produced, so there must be nitrene can be produced. POAT whole 3, that first nitro convert into nitroso group and then it must be produced nitrene intermediate. Okay, nitrene should be behave like electrophile and undergo addition, insertion, rearrangement, so many types of reaction. Now we have to go reaction. First one, addition reaction, it can be added with the any type of alkene. Okay, that is called addition procedure. Next one, it can be produced here ring formation. Okay, and insertion, it can be inserted in between of carbon hydrogen bond. Okay, here nitrogen can be inserted in this carbon hydrogen bond. Okay, carbon hydrogen bond, here nitrogen inserted, so this produced. And last one, rearrangement reaction. In rearrangement reaction, you know, this paired electron go this way and this R group go this way, so there isocyanate can be produced. Here Cartesian reaction, N2 release, isocyanate can be produced, nitrene as an intermediate. Here alkyl azide, so there must be nitrene can be produced, and NR double bond C RR can be produced. Okay, again there must be CONH needs to produce nitrous acid, produce azide, and then ring formation, then beta phenylalanine can be produced. Then Hoffman rearrangement, Br2KOH produce ethyl, K2CO3, again there Br release, alkyl isocyanate can be produced, there must be COOH produce, amine can be produced. Application, there must be OH can be react carbonyl, so this bond can be break, so there this produce, again Br2AOH can be used, there must be this produce, and then beta alanine. There must be the famous reactions that I forget in that time in present type, but There must always same, but from amide to amine, Br to KOH can be used. Okay, from amide to amine production. आपको amide से amine प्रोड्यूस करना है तो आपको Br to KOH यूज़ करना है. ठीक है. हाँ, मुझे अब रिएक्शन का याद नहीं आ रहा है, पर बहुत ही फेमस रिएक्शन है. Next one, Smith reaction or reagent. There should be any type of acid that should be react with HN3. I think this is called hydazoic acid. This type of name should be there, and then there must be react to produce ultimately nitrene. This nitrene can be again react to produce NR double bond C double bond O, and again water can be react and decarboxylation CO2 release, and what that is amine produced. Next one, Lawson reagent, also reaction. Hydroxamic acid, there also as this OH can be acylated, that is called acyl derivative of hydroxamic acid. There should be the internal reagent can be there, acyl group release, so NR RN double bond C double bond O can be produced. Water when react there must be COOH produced. After that there should be decarboxylation, this amine and CO2 that should be released. And electron donating group accelerate the reaction procedure, and electron donating group rate that should be decreased. So this is nitrene that should be completed. After that I will discuss on benzene. Okay, thank you.